Hello everyone. Today in this video, let us discuss all the solutions of these questions from exercise 1.3 based on theorem 1.3 and 1.4. All the proofs for irrational numbers. So let's start. Let us see the first question. Prove that root 5 is irrational. You need to prove that root 5 is irrational. In contrary to that, let us assume root 5 is rational. Rational means which can be written in the form of a by b. So I can write root 5 as a by b, where a and b are integers and b not equal to 0. For here you can think a and b is in simplest form also. That means a and b are co-prime. Co-prime means they don't have any common factor other than 1. So root 5 is equal to a by b. By doing cross multiplying, you can write that a is equal to root 5 into b. Then squaring on both sides, we get a square is equal to root 5 into root 5 is 5, b into b square. So a square is equal to 5b square. That means a square is equal to 5 into b square means 5 into some number. A square is 5 into some number. That means 5 exactly divides a square. So 5 divides a square exactly. So if 5 divides a square, then by theorem 1.3, we know that if p divides a square, then p also divides a by theorem 1.3. So here also you can write if 5 divides a square, then you can also think 5 divides a. Okay, if 5 divides a, we can write it as a is equal to, on the right side, a is equal to 5 into c. Because a divides 5 divides a, we can also write a is equal to 5 into c, where c is any integer. So now here a is equal to 5c we got, right? So this one we substitute in this previous one. You think this as 1. A square is equal to 5b square, you substitute. So a is equal to 5c, you get in 1 as 5c whole square is equal to 5 into b square, which you can write as 5 into 5, 25c square is equal to 5b square. So by doing cancellation, 5 ones and 5 5s here. So we can write 5c square is equal to b square. That means also you can think b square is equal to 5c square. So if b square is equal to 5 into something, you can say that here 5 also divides b square exactly. So because b square is equal to 5 square, so 5 also divides b square exactly. 5 divides b square means by again theorem 1.3 we can say that 5 also divides b exactly. So therefore by theorem 1.3 5 divides b. Now you observe here, previously we got just now 5 divides a, and here now you are getting 5 divides b. So what do you mean by that? 5 is dividing both a and b. That means a and b have at least at least 5 as common factor. But what we think, this is contrary to that what we have thought in the beginning, a and b are co-prime. In the beginning we thought as a and b are co-prime. Co-prime means they don't have any common factor other than 1. But here we are getting 5 as a common factor for a and b. So if 5 is a common factor of a and b, this is a contradiction to this. So this contradiction arises due to our assumption that root 5 is rational. So we can write finally that root 5 is irrational. Now let us see the second question. Prove that 3 plus 2 root 5 is irrational. We need to prove that 3 plus 2 root 5 is irrational. For that, in contrary to that, let us assume, as we did before, let us assume 3 plus 2 root 5 is rational number. Instead of irrational, let us assume that it has rational number. Okay. Now, if it is a rational number, what you can understand, you can write it as in the form of a by b form. which is rational number form. So 3 plus 2 root 5 can be written as a by b, where a and b are integers and b not equal to 0. Here you can also think a and b is in simplest form, or a and b are co-prime. Co-prime in the meaning is they do not have any common factor other than 1. Okay, now coming to here, if 3 plus 2 root 5 is equal to a by b, we can write as 2 root 5 is equal to, sending 3 to the other side, we can write a by b minus 3. So let us simplify more. By 1 you write and take LCM and simplify this. So we can write it as b as LCM into 1 a minus into b gives you 3b. So a minus 3b is equal to 2 root 5. Right? Now, if I take root 5 is equal to, sending 2 to the other side, I will get a minus 3b by 2 into b. 2 comes into the denominator, 2b. Now, as a and b are integers, as we thought in the beginning, a and b are integers. So, a minus 3b by 2b also totally irrational number. Numerator is an integer, denominator is also an integer. As a and b are integers, a minus 3b numerator is an integer and 2 into b is also an integer. So, finally, numerator and denominator are integers. So, that means you can think this as rational number. So, a minus, as a and b are integers, then a minus 3b by 2b is also is a rational number, because numerator and denominator are integers. So, it is a rational number. If it is a rational number, what do you mean by that? Actually, that is equal to root 5 here. So, that means root 5 is also should be a rational number. So, let us write. Therefore, that means root 5 is also a rational number. But what did we learn previously, in just before the previous question? So, root 5 is irrational, we have learned. So, we proved and we have learned that root 5 is rational. We proved and learned that in the previous video also, that root 5 is irrational. Root 5 is irrational. So, we got a contradiction again here. We got here a rational, but we know that root 5 is irrational. So, this contradiction arises due to, again, the incorrect assumption. Again, incorrect assumption that 3 plus root 5 is irrational. In the beginning, we have thought that this contradiction arose due to incorrect assumption that in the beginning, what we have thought, 2 plus 3 root 5 is rational, we thought and started. So, 2 plus 3 root 5 is not rational. Now you came to know that. So, we conclude that two plus 3 root 5 is irrational. So, what did you understand from this? 2 plus 3 root 5 is irrational means the sum of a rational number and irrational number is irrational again. So, you can also conclude that the sum of any rational, 2 is a rational number, 3 root 5 is an irrational number. So, sum of rational and irrational is always irrational. You can also conclude to that. Now, let us see the question number 3. The third question is, prove that the following are irrationals. The first one under that 1 by root 2, second one 7 root 5 and third one is 6 plus root 2. This we need to prove as irrationals. So let us take one by one. The first one is 1 by root 2. We need to prove it as irrational. So in contrary to that, let us assume that 1 by root 2 is rational number. We need to prove it as irrational, but we think it as rational and start. So, if 1 by root 2 is rational, then it can be expressed in the form of a by b form. Because every rational number can be expressed in the form of a by b, where a and b are integers. and b not equal to 0 because denominator cannot be never 0. So okay, 1 by root 2 is equal to a by b. Then if I can cross multiply, I can write it as b is equal to a root 2, a into root 2. Now you can understand that you can bring 2 to this side. Root 2 is equal to b by a. You can also write root 2 is equal to b by a. So what did you understand? Root 2 can be expressed in the form of b by a. So where b and a are integers, as we have thinking before that. A and b are integers. So if a and b are integers, then b by a is also a rational number. So b by a is rational number. As a and b are integers, we can write b by a is a rational number. If b by a is a rational number, that means b by a is equal to root 2 here. That means root 2 also should be a rational number. So if b by a is a rational number, then root 2 is a rational number. But what do we have learned? Is root 2 a rational number? We have already proved root 2 is not a rational number according to theorem 1.4. Root 2 is not a rational number. It is irrational. So this contradiction arises due to thinking that 1 by root 2 is rational number. So this is a contradiction to the fact that root 2 is irrational. So this contradiction arises due to our starting assumption itself. So let us come back to the previous contradiction. We write now together, like therefore this contradiction arises due to our assumption. You need to write this all to prove this irrational, that 1 by root 2 is rational we thought. So therefore 1 by root 2 is irrational only. We can conclude that it is not rational because of the contradiction. We come back to our word that it is irrational. Let's see the second question. Now let us see the second one in this. 7 root 5 is irrational. You need to prove that 7 root 5 is irrational. Again, in contrary to that, we will assume that 7 root 5, let us assume that 7 root 5 is rational number. Let us think it as rational. So if it is a rational number, it can be expressed in the form of a by b according to the rational number definition. So 7 root 5 can be expressed in the form of a by b, where a and b are integers and b not equal to 0. This is the definition of rational number. So if 7 root 5 is equal to a by b, then you can write b into 7 root 5 is equal to a. Okay, next I want to put root 5 here and send b into 7 to the other side. So you can write as a by 7 into b, b into 7 or 7 into b. So root 5 is equal to a by 7b we got. Since a, b are integers, here a is an integer, b is an integer. So a by 7b is totally a rational number. Numerator is an integer, denominator is also an integer. Since a comma b comma 7 are integers, then numerator and denominators are integers. Therefore, we can say that a by 7b is a rational number. If it is a rational number, what do you mean by that? A by 7b is equal to root 5 this side. So that means a by 7b is a rational number, means root 5 also should be a rational number. Is also a rational number. But we have learned that root 5 is irrational. We have learned that root 5 is irrational already, we proved. But we proved that root 5 is irrational. So this is a contradiction. So this contradiction arises due to our starting assumption. So this contradiction arised due to our incorrect assumption. We need to write like this for every question in the last. Incorrect assumption that, what is that assumption we started? We started as 7 root 5 is rational, we thought. But this is a wrong statement. So therefore we can conclude that seven root 5 is irrational. This type of questions all we will start with the contrary, and we prove that some contradiction arises in the middle. Then we come back to our sentence and we prove that it is irrational. So the product of a rational and irrational here. Observe 7 into root 5. 7 is a rational, root 5 is irrational. The product of rational and irrational is irrational. You can also conclude that statement. Okay, we'll go to next. Let us see the third question in the third one. 6 plus root 2 is irrational. You need to prove that 6 plus root 2 is irrational. So in contrary to that, as usual, let us assume 6 plus root 2 is rational number. Instead of irrational, let us assume that it is rational. Again, so if it is a rational number, you can express it in the form of a by b in the fraction form. So 6 plus root 2 can be written as a by b, where a and b are integers and b not equal to 0. Okay. Now coming to here, 6 plus root 2 is equal to a by b. So root 2 is equal to, sending 6 to the other side, a by b minus 6. Taking LCM, 6 by 1, b and 1 LCM is b. b into 1, a into 1, a minus 1 into b, 6 into b. So 6b. So you will get a minus 6b by b is equal to this side root 2. Now if a, b and 6 are integers, already you know a and b are integers and 6 is also an integer. So if a, 6, b are integers, numerator a minus 6b is an integer and even denominator b is also an integer. So finally numerator is integer, b is an integer. So you can think that a minus 6b by b is totally a rational number. If numerator and denominators are integers and b not equal to 0, we can call it as a rational number. So as a comma b comma 6 are integers, so this is 6. A minus 6b by b is a rational number. Is a rational number. But what is this a minus 6b by b? This is equal to root 2 here actually. So that means root 2 is also a rational number. So as it is, this side is a rational number, root 2 also should be a rational number. If it is also should be a rational number, but we know that root 2 is not a rational number as we proved. So root 2 is not a rational number. There is a theorem also. So we already proved or know that anything. Already proved that root 2 is a irrational number. So if it is irrational number, but we got here rational number, so the contradiction arised. So this contradiction arised due to the fact that as we assume 6 plus root 2 is irrational. So this contradiction arised due to our incorrect assumption that, what is that? What we assumed in the starting, 6 plus root 2 is rational we thought and started the whole thing. So that means this is a wrong statement. We got a contradiction means this is a wrong statement. So we can conclude this. Therefore 6 plus root 2 is irrational. You can prove like this. So in that way you can say that we can prove that 6 plus root 2 is irrational. Let us meet in the next video. Bye.